well, hey y'all, I am going to attempt to do notes on my Mac, which I'm not sure if I've ever done before. So it's recording the screen. There's a really important lesson today for tomorrow, I guess. Well, for Wednesday, a really important lesson. No, wait, today is Wednesday, Thursday, about Pythagorean theorem and the distance formula. So I want to be really, really specific. I am going to give you guys an exit ticket. I'm going to give you both the Pythagorean theorem and a distance formula problem. So I'll do one on Thursday, probably one on Friday. Okay. I'm going to be very specific about the form. So pay attention to how I'm showing you how to do it. I will not allow you guys to write it all ugly, all over the place, without writing the formula. You must write the formula first. So here we go. Let me make sure. Oh, cool. I took off the touch. All right. So the Pythagorean theorem. I'm assuming everybody knows what the Pythagorean theorem is. Wait, let me lock everything down so I can write on it. Lock all. Okay. Let me get the right color pen. I don't know. How about purple, guys? All right. So the Pythagorean theorem is this. You need to know this by heart. A squared plus b squared equals c squared. Now, the most important thing about the Pythagorean theorem is that you know that c is the hypotenuse. Okay? C is always the hypotenuse. The hypotenuse is never A or B. A or B, it doesn't matter which side you pick for A or B, but C must always be the hypotenuse. All right, when you are solving these problems, I don't want you to remember any other formula except for this one for Pythagorean. I don't want you to remember that a side is equal to A squared equals C squared minus B squared. I don't want you to learn any other forms, just this one. We will manipulate it through algebra and it'll be easy. Okay, for me, this is what I want you to show me. You need to show me formula, substitution. Write this down, guys. Resolution. You must show all three. That means I want you to write the formula first. Okay, the formula goes first, then you substitute in the values that you have, and then you solve it. Okay, that's what resolution means. So for this, first you're going to write, okay, first of all, why would you use the Pythagorean theorem? I guess we should talk about that first. Okay, Pythagoras was a mathematician back in ancient Greece. I don't know a whole lot about him except for that he was crazy and he ran kind of like a weird culty um, sect where they were considering the Pythagoreans, I think, and they were a group. Anyway, all right. He did come up with this theorem: a squared plus b squared equals c squared. Of course, but they didn't even have letters back then. They just said the sum of the square of the two sides is equal to the square of the longest side, something like that. Anyway, where you use it, or when you use it, I should say, or where, when you have a right triangle. Pythagorean theorem is for right triangles only. Only right triangles, okay? So if you have a right triangle, the beauty of this theorem is that if you have two sides, you can find the other side. That's amazing, you guys. All you need are two sides of a right triangle and you can find the third. That's pretty cool. So here's how we do it. First, identify the hypotenuse. This is C. You always want to identify the hypotenuse. It's always going to be opposite the right angle, but it's always, you usually can tell that it's the longest side, but sometimes it can get a little weird and, you know, they move the triangle around. So look for the right triangle and it's going to be the opposite. All right, so first, for me, this is what you must do. You must first write a squared plus b squared equals c squared. Then you're going to substitute it in. I don't care which side you pick for a or b. Just pick one of them. I'm going to pick this for my a. 6 squared plus x squared equals c squared. Now, I kind of didn't read the directions because I already knew what they were going to be, but you know what I mean? They wanted you to find side length x. Okay? Round your answer to the nearest hundredth. Okay, so, all right. So notice I did formula, substitution. I've done those too. This was the formula. This is substitution. See, I substituted in. And 3 means do the math. 6 squared is 36. Plus x squared is equal to, and I forgot to substitute in there. I bet there's some people that noticed. 10 is equal to c. 10 squared. There, now I substituted in. Okay, 100. Then you subtract 36 from both sides because remember, we want to get the x squared by itself. Cancel. I ran out of room, so I'm going to go over here. X squared is equal to 64. 100 minus 36 is 64. Now to get this x by itself, we take the square root of both sides. The square root of x squared is x, and the square root of 64 is 8. All right, it says to the nearest hundredth. I don't think you need to put 0.00, but honestly, I'll never know with Alex. So it is 8. It's a nice, neat one. This is what you call a Pythagorean triplet. It's one that ends up with like beautiful integers. 8, 6, 8, 10 is one. 3, 4, 5 is one. 5, 12, 13 is one. You don't need to know that right now, but they have these perfect triangles that are they're just so nice and neat. All right. Normally you would use the calculator and you would use the square root button to get the square root of 64. Okay. Hopefully you guys already know it. Okay, let me go ahead and move this down. There we go. It says, for the following triangle, find the side length x. Round your answer to the nearest hundredth again. Okay, so here we are. Okay, I changed colors because why not? All right, identify. First thing you go, oh my gosh, look, it's a right triangle. That means I can use the Pythagorean theorem. Yay! Identify the hypotenuse. The hypotenuse is opposite the right angle, and it is x. So, formula, substitution, resolution. So first, the formula. Then substitution. I'm going to call 12a. It doesn't matter. I could call a or b. We can interchange those. It doesn't really matter. But c is x squared. All right? Now, that's formula. This is substitution. Notice I'm keeping everything nice in line. Resolution. 144 plus 64 equals x squared. Do the math. Add these two together because you can. 4 plus 4 is 8. 6 plus 4 is 10. Carry the 1. 808. No, that's not right. Sorry. Wow. Sorry, Miss Baca. Geez, woman. All right, here we go. Equals x squared. Now you're going to take the square root of this side, take the square root of that side. So you go get your calculator. Pretty sure it is recording. If it isn't, I'm on a calculator. Did you guys know you could do this? Hang on a second. Let me go back to Ziteboard. This is called Ziteboard, by the way. We want the square root of 208. I think you can type it in the Google bar. I think you're going to go square root 208. I don't know if you guys knew this. There you go, 14.42. Isn't that cool? All right, you can do addition and division and everything in that Google bar. It's pretty cool. But anyway, if you want to get to calculator, it's nice. 14.42, okay? 14.422222 is actually what it said. So we want to round it to the nearest hundredth. Hundredth is 2 decimals past. So 42222 is less than 5. So this is your answer. Okay, next. I'm doing a few of these just so you get the hang of it, okay? I'm trying to do different sides. In this case, here we go. We've got a right triangle. They want us to find x. We can use the Pythagorean theorem. Formula, substitution. I'm going to substitute x for a and identify your hypotenuse. Always, hypotenuse is the longest side. Okay? Then do the math. Resolution. 8 squared is 64. 16 squared is 256, I think. Yep. 256. Subtract 64. So again, you can go back up there. You could do 256 minus 64. I'm just doing it by hand because I actually like working by hand, you guys. 192. And then you're going to take the square root of both sides. So take the square root. That undoes that. Take the square root of 192. I'm going to go over here. I'm going to go square root of 192. So I'm going to go here. Clear that. Right, 192. Take the square. Oh, no, sorry. I am used to working on a calculator backwards. The square root, I'm not used to working forwards like this. Okay, square root of 13. Okay, so it's 13.856. 6 is larger than 5. So that's going to round up to 13.86. Okay, 13.86. Here we go. So 13.86. All right, so that should get you to where you need to be for Pythagorean theorem. Now, I'm not going to do this in the notes, but there is a formula called the distance formula, actually, and it's totally related to the Pythagorean theorem. I will derive it in class, but not here on the notes. You can use the distance formula to find the distance between 2 points. But here's the thinking here. I'm going to make it bigger so you can see it. So we can see where exactly it is too. Okay, so it actually gives you the points up there on the top. If you didn't notice, let me see if I can't get it to go down a little bit. Here we go, there. It gives us the points CE. C is 4, -3, E is 7, -7. Okay, so what you can do is you could draw a triangle here. Now, I'm not going to recommend that you do this. Seriously, I'm not going to recommend that you do this. But you could draw a triangle like this, a right triangle. It's called dropping down the perpendicular. And then you could figure out what this distance is. So it looks like it goes from -3 to -7. So that's 4. And this looks like it goes from 4 to 7. That would be 3. So then you'd have two sides, and then the distance, you could use a squared plus b squared equals c squared. Well, this isn't always practical, or it isn't always great. So you're going to have to learn the distance formula, okay? I have no fun little way to remember this. But the distance formula is used to find the distance between 2 points on a Cartesian plane. All right, this is a Cartesian plane. You may not know it. This is a Cartesian plane. A man named Descartes came up with it. And so it's just basically how we lay out our grid. Okay, so we are looking at, I'm going to go ahead and move down. I'm going to actually shrink it down a little bit so that we can find the points, okay? So the points are 4, -3, and 7, -7. So again, I want you to use formula, substitution, resolution. So I'm going to give you the formula right now. Here it is. It goes d, and it's a little d, not a big D, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All of this is under a square root. All right, so what do I expect you to be able to do? I expect you to be able to take these 2 points, this 4, -3, and this E, 7, -7, and plug them in. So I'm going to change colors real quick. Okay, just to make it very clear what I'm doing. Okay, pink. E is going to be pink. 7, -7. Okay, so what we're going to do is we're going to plug these 2 points into the distance formula. So we're going to call this one, let's call this one, we'll call this one x1, y1. Basically, you guys, the only thing that x1 and y1 mean, it means the x and the y of the point, of the first point. We'll call this one x2, y2. Okay, so this means this is just the first point, this is the second point. It doesn't matter which point you pick for the first and the second, as long as you keep them organized like this, in the sense that you keep x2 and y2 together. All right, so here we go. You get the formula, then you plug it in. So I've got d is equal to this square root. Now we're going to plug in x2. So x2 is 7 minus x1 is 4. See it? It's right here. Quantity squared plus, then y2 is -7. Okay? Yeah, it's okay if I picked weirdo purple instead. Okay, here we go. Minus y1, which is -3. See how I did that? Okay. Formula, substitution, resolution. Do you guys see this? Hopefully you do. Look, all I've done is copied these things down. So here's my minus sign. There's my minus sign. The 4 was positive. See, I plugged in the 4 for x1. Here's my minus sign. Here's my minus sign. I plugged in a -3 for y1. See? Okay. So then now all you do is do the math. Okay, so we're going to go d equals the square root all of. Do the parentheses first, PEMDAS. That 7 minus 4 is 3 squared. -7 minus -3. These are two negatives. That becomes a positive. I'm going to do it in a different color, just so you can see that I'm going to add the opposite. That becomes a positive. So then this becomes -7 plus 3 rather is -4 squared. Keep going. Wrong way, wrong way. Let's try to go the right way. Come on, honey. There it goes. Okay, so here we go. D equals the square root of, and then now we do 3 squared. 3 squared means 3 times 3, 9. -4 times -4 is +16, right? -4 squared is +16. Now you add them together and you get 9 plus 16 is 25. And guess what? The square root of 25 is 5. And that's your answer. The distance between these 2 points is 5. And that's how you found it. Now, notice, I could have used the Pythagorean theorem. A squared plus b squared equals c squared. 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. Take the square root of both sides, and you'll get c equals 5. Now, I understand this seems a little bit easier right here, but you have to learn how to use the distance formula because you're not going to always have a grid. And it's not going to always be possible to draw this triangle like so easily. So I'm going to make sure you know how to use this formula. So be prepared to use it. Memorize it. D is equal to, but put it in your notes. Since we are doing x2 minus x1, since we are doing these classes virtually, definitely want you to have this on hand in your notebook, okay? All right, that's the formula. So first step, write the formula. Second step, substitute it in. I'm going to give them colors. Let's do, this one is orange. E is -6, 8. And L is going to be green. and it is negative 1, 1. All right, so now we're going to substitute it in. I'm going to say that this one is x1, y1, and I'm going to say this one is x2, y2. Okay, x2, y2. All right, so now we're going to plug it in. I'm looking for x2 and x1, so here goes. Okay, I'm going to plug them in. I'm going to carry down all of the pieces parts. This is the part of the formula that I leave the same. I bring down everything. Now I just need to plug in the parts. See? I carry down the parentheses, the squared, the parentheses, the squared. All right, so here's x2. x2 is negative 6. So we're going to plug in negative 6, and x1 is negative 1. So we're going to plug in a negative 1. See what I did? Negative 1, negative 6. All right, y2. y2 is 8. So we're going to plug in an 8. x1, y1 is 1. So we're going to plug in a 1. There you go. Now that you've plugged in all the parts, all you need to do is keep solving the problem. So formula, substitution, resolution. This is how I expect you to do it. And I don't want to have to explain it in class necessarily. I think you guys should get it from the notes. So make sure you are. This negative of a negative becomes a positive, right? Negative times negative is a positive. And if you can't see that that's a negative times negative, remember you can always put a 1 here. That makes it look like a plus. I don't want to do that. Okay, but minus minus becomes plus. So it's negative 6, negative 6 plus 1. I'm doing that for the people that need that. And this is going to be 7. Okay, negative 6 plus 1 is going to become negative 5 squared. I need to keep it in parentheses or else it's not the right problem. This one I can take out because it's positive. Actually, let me just figure that out. Why not? 7 squared is 49. D is equal to the square root of negative 5 squared is 25 plus 49. D is equal to, I swear, I could do a million problems and I will always run out of room for my final answer. 25 plus 49 is 74. Yeah. And it says, give an exact answer. All right. So I'm trying to remember how much we've done of this. Hang on. I'm going to cough and I need to take a drink. All right. To give an exact answer, I believe we did this square root in the prep. I'm not sure if we did. And if we didn't, I guess we might have to go over this. But what you want to do is 74 is the answer right here. Okay, I don't need this huge long line, right? I can do a shorter line. Okay, well, 74, it says do not do a decimal approximation. It's really nice when you just plug that into a calculator. But what it wants you to do, and what we do all the time in geometry, is we try to break this up into perfect squares. I'm going to do this now. I'm going to ask you tomorrow. I don't remember if I've done this. I have so many different math classes. It's hard to remember. So you guys, perfect squares. These are perfect squares. Perfect square numbers look like this. It's 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. Do you see it? These are the perfect square numbers. 49, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, 13 times 13, 14 times 14, 15 times 15. I don't know, something like that. Okay, and then it keeps going. But basically, these are the square numbers. What you have to do when they're looking for an exact answer, and I'm definitely going to work with you on this skill, you need to break apart 74. You need to ask yourself, is there a perfect square that goes into 74? I'm not sure that there is, you guys. Okay, but I know 2 goes in there. So I'm going to check it out real quick. 2 times what is equal to 74? Is that right? 37? Okay, guess what? I guess we're not breaking it up. Maybe we're not breaking it up this time because you can't break this up. 2 is prime and 37 is prime. There's nothing we can do. So guess what? This is the final answer. You have to just leave it as the square root of 74. Okay? We will eventually be breaking these up. I'm glad that they didn't do that right then. All right, this one says to round to the nearest hundredth. Again, I'm doing a lot of these on purpose so that you get used to them, okay? So I'm going to call this one, we don't even need this drawing because check it out. I'm going to call this one x1, y1, and I'm going to call this one x2, y2, okay? So then I'm going to write the formula. Formula x2 minus x1 squared plus y2 minus y1 squared. Okay, parentheses squared. All right, then in the next line, I'm carrying everything down that is part of the formula. And all I'm doing is substituting in. X2 is 9. Y2 is negative 8. I'm just going to put it in now since I have the same color. And then 5 and negative 1. Put it in parentheses. Okay, so now my distance is d is equal to the square root of 9 minus 5 is 4 squared plus, I don't need to put in parentheses because it's positive. When it's a negative, you absolutely have to have parentheses, okay? So negative 8, this becomes a plus 1, yeah. Negative 8 is negative 7 squared. Remember, negative 7 squared means negative 7 times negative 7, which is positive 49. Just as a side, just so you know, you guys, this is why I won't let you take off the parentheses. Negative 7 squared is equal to the negative of 7 times 7, because the base is only 7. And the answer to this is negative 49. This is not the one we want. We want this one. So it's positive 49. So 4 squared is 16. This is positive 49. 49 plus 16, 65. Square root of 65. And then you just leave it like that. Oh, wait, it says to the nearest hundredth. Never mind this. If they had this been an exact answer, then you would have plugged it into the calculator. I mean, you would have left it like that. Since it's a decimal answer, we're going to plug it into the calculator. And you get the square root of 65 and round it to the nearest hundredth. Okay, so 65. Oh, wait, sorry. I'm used to doing square root, 65 square root. We want to do, and now I'm trying to touch my screen because I don't know what computer I have. Square, oh my gosh, sorry. Can't use two hands, got to make sure I'm doing it. Square root of 65, 8.062. 2 is less than 5, so we don't round up, we stay there. So it's 8.06. Okay, next one. Okay, last one for distance. Again, it's nearest hundredth. Okay, let me just check something really quick. I'm going to go back. That was nearest hundredth. That was an exact answer. This was an exact answer. Oh, but it worked out to be a nice one. I was like, I know I picked 2 exact answers. All right. So take a look at this. Okay, again, x1, y1, x2, y2. I'm not going to switch colors this time. Square root of x2 formula substitution y2 is 4 minus negative 3. By the way, whenever I do problems like this, I need to put another one of those. You can always pause the video like ahead of the time that I do it. If I'm doing multiple problems, what I highly recommend you do is pause the video, try the problem on your own, and see if you got it right. Okay? D is equal to, this becomes a plus, minus minus is a plus. This becomes a plus. All right, back to this. All right, so 6 plus 2 is 8 squared, plus 4 plus 3 is 7 squared. D is equal to 64 plus 49. D is equal to the square root. Now add those two together. 9 plus 4 is 13. Carry the 1. 11. 113. Now you need to plug that into a calculator and round it to the nearest hundredth. I'm going to let you guys, well, I'll just do it. What the heck? 113. So square root of 113. Boom. 10.63. Okay. I told you I always run out of room. Never fails. Next. All right. This is the last one. I'm pretty sure. Yes. I didn't do two of these because I feel like at this point you're kind of getting it. But it says using the Pythagorean theorem. Wow. Sorry about that. Let's try not let's underline. Okay, to find distance. So this was actually supposed to be before this. I don't know how it'll come out with Alex, but what you're going to do is notice what they did is they didn't give you points. Okay. So you're literally going to be drawing a little triangle and then naming the distance. This distance is 1, 2. This distance is 1, 2, 3. And they want to know what this distance is. This is the hypotenuse. So formula, Pythagorean theorem, substitution, resolution. Why did I do that? 4. 2 squared is 4. 3 squared is 9. C squared. 4 plus 9 is 13 equals C squared. Take the square root of both sides, and you will get the square root of 13. And then if you have to round it to the nearest hundredth, okay, again, square root 13, 3.6. Oh, look at the 5 is bigger. It's 5 or greater, so we're going to round it up to 3.61. Okay, be prepared to be able to answer a Pythagorean theorem question when you come back to class. Okay, if you need to study it, do it. Okay, but that's what you're going to need to do. I am going to give you a problem like, okay, something like this. Okay, I'm going to give you a triangle and then give you a side to solve. And that's all you have to do. Okay, all right.